Okay, so this morning we're going to look at converting fractions. Now we learned, didn't we, that there are three types of fractions. There's common fractions or vulgar or proper, they're called all those different things, where the numerator is smaller than the denominator. Then we have improper fractions, where the numerator is bigger than the denominator. And then we have mixed numerals, where we have an integer, which is a whole number, and a common fraction. So let's have a look at some examples of that. Improper fractions, we've got 7 over 4, or 9 over 5, or 11 over 6, or 12 over 11. They're all improper fractions, aren't they? Because the numerator is bigger than the denominator. Mixed numerals, we've got 2 1/2, 3 3/4, 4 1/3, and of course 9 3/4. We have to have that one, don't we? 9 3/4. You have to do notebooks open and writing the notes. So what we're going to look at today is, if you are given an improper fraction, we're going to look at how you convert it to a mixed numeral, and vice versa. If you are given a mixed numeral, we're going to look at how to convert them to improper fractions. So let's look at those improper fractions then. We've got 7 over 4, 9 over 5, 11 over 6, and 12 over 11. So this is where you need to be good at dividing, okay? Because what we have to do is we have to work out how many whole ones are included in that 7 over 4. So if you imagine you've got 7 quarters. So let me just draw that pictorially for you so you can have an idea. You've got 1, 2, 3, 4, 5, 6, 7. So how many whole ones have you got?
1.
1, that's right. And then how many quarters are left over? 3 quarters, that's right. So if you didn't have a diagram and you had to do it another way, what you do is you say, how many 4s are there in 7? There's 1. And then how many quarters left over? There's 3. And then the denominator stays the same. Okay, the nice thing about these, converting there to there or there to there, is that the denominator never changes unless you have to simplify it. So here, 9 over 5. How many 5s are there in 9? 1. The denominator isn't going to change, it's a 5th. How many are left over though? 4. So it's 1 4/5. Okay, this one. How many 6s are there in 11? 1. And how many left over?
4. Oh, 5.
5/6 left over, that's right. And then the last one, 12 over 11. How many 11s are there in 12, Lachlan?
1.
With 1 11th left over. Now they were all fairly straightforward because we all had 1. So what about if we had a slightly more complicated one? Let's have a look at something like 36 over 5. Now that's a lot bigger, or 43 over 7. They're bigger. But you do it in exactly the same way. Remember, you're going to end up with a whole number and a common fraction with the same denominator, a whole number and a common fraction with the same denominator. So, how many 5s are there in 36? Oh, lots of hands went up then. Casting.
7.
7. And how many left over? 1. So it's 7 1/5. Okay. This one. How many 7s in 43?
6.
With how many left over?
1.
1. 6 and 1/7. Is it making sense to people? Good. Okay. So that's how you do that when you have to see how many divide into the top number and how many are left over, and make sure that you keep the denominator the same. Right, so we're going to try it the opposite way now. So we'll have 2.5, 2.5, 3 3/4, 4 1/3, and 9 3/4. Now for this one, if you've got 2 whole ones, oh well, what can I put in first before I even do anything else? What's not going to change in any of the questions?
Denominator.
The denominator. So let's put the denominator in there. It's going to be over 2. That's going to be over 4. That's going to be over 3. And that's going to be over 4. So we know that already, don't we? Because the denominator's there. So if I've got 2 whole ones, say imagine 2 pizzas, how many halves have I got?
4.
Good, 4. And then I need to add this extra one in. So how many have I got then?
4.5.
You haven't got 4.5 halves, have you?
Oh.
There's 4 halves in there, and 1 extra half makes how many halves?
5.
5 halves, that's right. 5 halves. And the way that we did that was we multiplied those 2 numbers together and then added that one. 2 times 2 is 4, add the 1 is 5. This one then, if I've got 3 whole ones, how many quarters do I have?
12.
12. And then I've got to add these 3.
15.
15, that's right. So the way we did that, 3 times 4, and then add the 3. This one, if I've got 4 whole ones, how many thirds do I have?
4.
If I've got 4 whole ones, all divided into thirds, how many thirds do I have? 12. And then we add this one in, gives us 13. And this one, 9 3/4. In 9, how many quarters are there? 36. Add the 3, 39. Well done. So, platform 9 3/4 could also be called platform 39/4. Okay, maybe we should write to J.K. Rowling and tell her that we want to change it to an improper fraction. So, you can see, can't you, that it's quite easy. If you know your multiplying and you know your division, converting is pretty easy. So let's just do one more. We'll have a bigger one of this and see how we go. 6 6/7. Okay, have a go at that one for me. 6 6/7. What do we know is going to be part of the answer? Yeah, 7 is going to be a denominator. Well done. So what is the new numerator? Come on.
48.
48, well done. 48/7. Okay, stop there then for me, Tara.